let's have a look at some examples in dilation graph drawing. I'll try to show you some common traps for new players. So, the first one, what should we concentrate on? We should concentrate on the two numbers that's going to affect the shape. Let's talk about the 3 first. The first one is a dilation by a factor of 3 in the y direction, or you can say it's parallel to y. This little symbol means parallel, or it's perpendicular to the x-axis. The 2, remember, it's 1 over whatever that number is, so it's factor over half in the x direction, parallel to x, perpendicular to y. Let's have a look at this one. What is the shift? For new players, you might say it's being shifted this way by 2 units. That's incorrect, because you have to factorize the top in order to see the shift properly. So you can see that the shift is actually 1 unit. So that's a common trap. Be aware of that. These can obviously come in different forms, you know. So remember to factorize it. Take the half out. That's a reflection. There you go. So this will allow you to see things clearly. So you might want to have a go at sketching this in your calculator, and this one, which is the same as this one, just to see the difference, how which way it rotates, which way it reflects. Let's have a go at an example now. This one, for instance. Key things we should focus on are that one, and that one. As always, let's start out with the original standard graph. And I'll try to show you, I will show you the important things you've got to show in a graph in order to get full marks. Over here is 1. Okay, don't forget the asymptote. Try to draw it as close to the x-axis as possible. We can apply these changes one after the other. I like to do the reflections first because it secures the shape, and then I'll shift depending on how many units or what kind of translations the graph requires. Reflections, this seems to be reflecting on both sides, so I'll use a different color. Let's do this one first. So that will result the graph looking like this. So it's a rotation this way. If you find it hard to remember, just remember that the original graph, the y equals, it can vary at different y values, has different y values. If you put a negative in front of it, just like how we have it here, all these are going to be negative. So for every single positive value, it's going to have an equal but opposite. That's how you remember it's rotating vertically. Of course, the asymptote stays the same. The second one, reflection over here, it's going to rotate it this way. It's going to have the same asymptote and the same cut, which is at -1. And finally, we're going to have a translation, a shift. So let's shift the asymptote first. The asymptote is at -1. oh, sorry, the asymptote is at y equals 0. The cut is at -1. We shift that up, it's going to be here. So that's our new asymptote. We're going to use that as a guideline. Okay. Again, a different color. The cut is going to be at 1. Because if you remember from before, what was the cut before? -1. How much has it been shifted? It's being shifted up by 2 units. And therefore, we try to maintain this shape, but have it cut here. Okay. Let's state the domain and range to complete the graph. Domain means what x value does it cover? Well, obviously, it looks like, use the x-axis as a guide. It looks like it's going to cover all positive x values. And on this end, it's going to go forever up because there is no asymptote here. There's no asymptote. It's going to go forever onto x negative, so you're going to have r, which means all numbers. Range. Okay, the range means what y value does it cover. So it looks like it's going to cover from this point, this asymptote point, which has the value of what? Of y equals 2. Does it include it? No, it doesn't. So we don't use square brackets. On the other side, it goes up to negative infinity. So, open bracket, negative infinity to 2. And that completes the graph. Would you get full marks? No, because you're missing one thing. That was a bit of a climax. Bet you didn't see that coming. So we're going to work out what that point is, and you can obviously work out with your calculator, but I'm just going to give you a value so that you can punch it in and confirm it. So we want the x cut, let's make y 0. Move the 2. Take log to the both sides. Let's use e to make it easier for ourselves. So remember the x can go down, and therefore we get x is equal to negative log e2. Just going to do a bit of showing off here. I'll put that negative back on top, and that becomes... So again, if the question asks you, if the x cut is equal to log e1 over a is equal to what? You've got to learn to manipulate it.